All right, Lisa, Lisa's friend, welcome back to the drive-thru for all your nerdy needs. I have no idea who this person is, which doesn't matter. I'm sure she's awesome because she's Lisa's friend, but I don't know what she understands. But I don't want to bore you, so I'm just going to try to help you with the answer to B, okay? A z-score represents how many standard deviations away from the mean that something is. So in this case, our mean, and we write mean like this, it's just our average. Our average drive goes 319.18 yards, okay? That's right here, right in the middle of our normal distribution, or our bell curve, okay, or our normal curve, I should say. And that's the average drive. Now, as you can see, our standard deviation, so like the distance away from the mean, is 5.99 yards. So basically, like, that's each standard deviation measures how likely something is to happen. So if you look at the first z-score, what you have to do to figure out the z-score, it's all you do is figure out how many yards away it is from the mean. So 319. Well, this is going to be negative, so I should do it right. It would be the actual, so 280 minus 319.18, and so that's the difference. So let me do that real quick. 280 minus 319.18, and you get negative 39.18. So that's how many yards away from the average or the mean that it is. We don't want that. We want the standard deviation. Well, we want the z-score. Well, each standard deviation is 5.99 yards, and the z-score is simply how many standard deviations away it is. So you take the difference and you divide it by the standard deviation, and so you get a z-score of negative 6.54. Now, I have a feeling this is what you're confused about. When you look at a normal z-chart, it doesn't even go past negative 3.4, because what this means is that, like, 0.03% of the data is to the left of that, and that's just if it's 3 standard deviations away. Ours, in this case, is 6 standard deviations away. So that means, like, that data point is literally like right here, and that means everybody hits it further than that on the tour. So the first z-score you put was 0. I think the z-score is this. I think we're maybe putting the percent of people that fall below that, okay? Now, the second z-score, I think, might make a little bit more sense. So I'll do that in blue. So for z2, you just take the new value, so 305, and you subtract the average, or the mean, 319.18, and then to find the z-score, you figure out how many standard deviations away it is, so you divide by what one standard deviation is. And let me do that as fast as I can. 305 minus 319.18 divided by 5.99. And okay, so that one's going to be on our chart. Our second z-score is negative, because it's to the left, 2.37. Okay, so when you go to the chart, you find negative 2.37, like you go negative 2.3, and you go across to the 7. Maybe you know how to do this, and that is what you get. So what that means is 0.0089, or 0.89% of golfers, pro golfers in this case, hit less than this, meaning just about every golfer, 99.11% of golfers hit it further than that drive. but this will allow you to answer your question. So your second z-score is this. So essentially, z1 is off the chart. z2 is like somewhere right here. And this blue shaded area represents the amount of golfers that hit the ball between 280 and 305 yards. Okay? And so what that is, you're pretty close, but it's as a percent. So you need to change this 0.01. We have to go back to what the answer is this. 0.89% of golfers hit the ball a distance between 280 and 305. I think that's right. I'm not sure. I hope this helps. Love you, Lisa. Boom!